Okay, for your warm-up, we've got a good variety of our law of signs questions. So let's take a look at the answers for those. Kind of a nice and easier way of seeing them, I think. Taking a look. Like I said, checking out y'all's classwork, the worksheet y'all did. Pretty happy with what I saw. I have a feeling we'll have some questions on the homework. Yes, sir? You got one more time? Yes? No, it's not. 4.7 is less than 6. Okay. Anybody else? Questions on those 3 problems? A little dancing, try to see them all. Ian, you're tall, but you're not see everything, huh? Okay, so we're good on those? Yes? If there are labels and you leave off labels, you're leaving off points. If that's not an annoying enough way of saying it. If you leave off labels. That is including angles. I'm seeing a lot of people leaving off their degree marks on your angles. Don't do it. Nope, you have to put the degree because there are multiple ways to measure an angle. Angles are measured in degrees and in radians. So that's why you want to make sure you're extra clear on that. All right, so for the homework, before we even kind of start going over it, please do not freak out about problem number 47. Okay? That was the one with the path going around the bay. If you got it right, you got it right. Fabulous. But I am not going to work through that one right now because I have a feeling I'm just going to stress everybody out if I do. So, any other questions on the homework? Yes, sir. 51. 51 gives us a situation that we see a lot in this class when we're talking about law of signs. And that is the fact that I have one angle. Let's draw let me draw it in. Here's our pyramid. So that's my pyramid. The height of that pyramid is what I'm trying to find. So that's what I want to find. I have this out here, though. So I have this piece here is 100 feet. That piece there is 200 feet. I have that angle is 40.3. And I have that angle is 46.27 degrees. And we're looking for the height. Well, what I want you to see with this, I don't really need this in here at all. It doesn't affect my picture. I don't have any measurements on it. I don't have any angles on it. I had that little piece was 100. The only reason why I had that was so that I could say, what is this piece here? 100. So what I'm going to do, it's not going to be drawn to scale, but I'm going to kind of like spread out my triangle a little bit so you can see what we're working with. So I'm just going to look at that triangle there. I'm purposefully not drawing it to scale just so I can fit these angle measurements in here. That's 40.3 degrees. This is 100 feet. I knew that I had an outside angle here, an exterior angle of 46.27 degrees. So what is that going to make this piece in here? What is that going to be? What is it? Did I leave a digit off of this? No, it should be 100 and something. 173.73. Yeah, I know that's kind of the bad thing when I spread it out. You can see where things are going a little easier, but it's not drawn to scale. So then what's this guy up here? 5.97? Okay, now in order to get this height here, I'm going to need either this side or that side. Because using those, I can then just reference the entire right triangle. Do y'all want me to find the A or the B? B? Okay. So if I'm going to find B, I needed this angle so that I had... Can you close the door for me, please? Somebody? Nada? So I'm going to have 100 divided by the sine of 5.97, because that's my angle side pair. You all chose to use B, so do B over the sine of 40.3 degrees. And then I need to find a calculator because that's not happening in my head. Okay, here we go. So I will do 100 times the sine of 40.3. Whoops. Close that parenthesis, divided by the sine of 5.97. And so I come up with that B to be equal to 621.867. So that's that piece right there. So now all I'm going to worry about is the triangle that has my X in it with the right angle, has 46.27, and has 621.867. Since this is a right triangle, all I need to do is use regular old trig. So which trig ratio do I use? Sine, because that's opposite and hypotenuse. So I will say the sine of 46.27 is opposite over hypotenuse. So I'm going to take that number, which is still in my calculator. I'm going to times that by the sine of 46.27. And so my final answer here from the height of my pyramid is 449.364. And my label here was feet. Feet. Words in the problem, some kind of a word or something in the answer. Wow, that is not showing up with anything. No. Why would you convert that to inches? Nope. Yes, ma'am? It's not a right triangle. It's not a right triangle. And if we're looking at this whole thing, yes, once I find that, but I don't know what this piece is here either. Okay, so Pythagorean theorem only works for right triangles. Okay? Anybody else for the homework? Sweet. So what we're going to do is y'all are going to be going to lunch in a second. When we come back, we'll just get right to the quiz. So make sure that your cell phones are in the holder in the back of the room when you come back and your desks are cleared, and we'll get right to it. All right, so what we've been working on up until now has been solving triangles, and we just finished doing solving with law of sines. Now, law of sines is great and all, but it only works if you have an angle side pair. If you do have an angle side pair, go ahead, use law of sines. It's nice. But remember that you got to be careful, because if you are only given one angle, sometimes that means you've got some possibilities. If you're given two angles, you automatically know what the third's going to be. You don't have much choice. It's okay. But if you're given one angle and two sides, then we sometimes have to worry about that ambiguous case. We have to check. Today, what we're going to be working on is what happens when you do not have an angle side pair. So maybe that means I have side A, side B, and angle C. See, those are not paired up in any way. Or maybe I even give you 3 sides. What do you do in cases like that? Well, law of sines works, and it's a simple calculation to put in your calculator, but it's not always good. So what we have is we have our backup plan, which is going to be the law of cosines. Now, before you get crazy writing all this down, let me tell you, I really only care that you memorize one of those. The one I just memorized the first one, because beyond that, they're the exact same thing, just reorganizing the letters. So go ahead and copy down one or all of your law of cosines. And let me be quite clear to you that the only thing you need to remember is that whatever's on this side matches that angle. You see, that's the only difference between these. We said, okay, what about all the other pairs? So go ahead and write that down. Law of cosines is a little bit more work to kind of like type into your calculator, but you don't ever have an ambiguous case with law of cosines, which is kind of nice. You guys have that little piece down? Again, I don't bother memorizing all of them. I just say, okay, what would have been my angle side pair that I'm trying to work with? I set those up, and then it's going to be the other 2 guys squared minus 2 times the other 2. And they're all that same way. All right, and the only thing you really need the picture for is just a reminder that your angle side pairs are opposite each other. Okay? So just don't forget that. We're not changing any of our general ideas here. So I usually don't even draw the pictures because I think it just takes up space. For something like this, whatever. So I'm going to do this the same way we've been doing all the problems. I'm going to list out all of my angles, all of my sides, and keep track of what I've been given. So I was given angle C is 41 degrees. That 29, what is that? Side A, good. And 13 is side B. Now, it's really important that whenever you're solving these guys, you're always indicating what the number represents. Don't just put it on the picture, because we need to make sure you understand angle A and side A are opposite each other. Okay, so you've got to make sure you're very clear on that. All right, so do we have what we need for that triangle? We don't have an angle side pair, but I have 3 pieces of information and at least one side. So what I need to do is I need to figure out what would be my angle side pair. So since that's the only angle that I'm given, these are the 2 that I'm going to work with. And I don't need to memorize the, when it's C, what do I do? All I need is to understand that I'm going to take whatever my angle side pair is, side squared is equal to the other 2 sides squared and added, minus 2 times the other 2 sides, times the cosine of your angle. Again, as long as those guys match, you should be on the right page. And that's just a matter of plugging stuff in. So I'm going to have C squared is 29 squared plus 13 squared minus 2, 29, 13, and the cosine of 41. Hey, guess what? You just type it into your calculator. Yay! Contain your excitement, everybody. I know you're sleepy. It's Friday. We can do this. Whoops. I hope you don't get the Augsburger disease. It's when you see something, but you can't seem to put it into your calculator correctly. I'm going to name it after myself. So, do you get your answers 440.949? No, that's wrong. She's like, well, the answer for the equation, because that's what c squared is. 440.989. Like, that's what I meant. So what do I need to do? Square root it. I'm going to take the square root of that shebang. And I come up with 20.999. That's not bad, is it? Okay. Now this next piece of information is very, very important. Is everybody awake and everybody paying attention? Because this is huge. A lot of other teachers will tell you, if you start with the law of cosines, you must finish with the law of cosines. I'm like, nah. If you know one thing, you don't have to do that, because using law of cosines to find angles is a little bit sticky. It's a lot of work. So here's my rule for you, okay? If you are going to switch to law of sines, you must do this. You must either already know what your largest side and angle pair is. What would be my largest side? 29. So do I have my largest angle? No. So either you have to have that pair, or whatever you do, don't touch it. Okay? Do something that you know is not the biggest. The reason why is actually the whole reason behind law of sines ambiguous case. If I swap over to law of sines now, it's going to only give me acute answers. That may or may not be the right answer. Okay? So we have to switch to something that I know is going to be acute. And since you can only have one obtuse angle in a triangle, as long as I'm not at the biggest side, I'm okay. So I'm going to find B next, because I know it is not the biggest. And I'm just going to do law of sines. So I'm going to say 20.999 over the sine of 41 degrees is equal to 13 over the sine of angle B. I only do this if I'm positive it's not going to be an obtuse angle. Okay, so I'm just going to solve it. Hey, yay, nothing different. 13 sine 41 divided by crazy other little number. Inverse sine, crazy little number. And I come away with B, 23.964 degrees. Are we in agreement? Because I'm not really good at typing things into my calculator. I know I screw that up a lot. You should have seen second block today. I either typed it into the calculator wrong, or I wrote it down wrong. Nothing came out right. It was awesome. Ever have those days? Sometimes? Is that every day? That's my life. Yeah. Okay. So, well, now that you know that, can anybody find what angle A is? Yeah, we got two angles in a triangle. What do they have to do? Equal 180. So I'm just going to take 180 minus that 23.964 and the 41. Boom, shakalaka. Good thing I didn't do angle A, because it is, in fact, obtuse. And da ist my answer. Da ist die Antwort. Hello. What do you need? For Sean? Okay, thank you. right, do we have any questions on that? So let's wait till the end of the class, okay, or other times during the day, okay? Because right now is not very convenient. We're still learning stuff. Yeah. All right, so draw the picture, just list out the things. I don't care, whatever you need. Let's go through number 2. All right. So, can anybody tell me how to set up my equation for this? Even if let's just use letters first. Let's just use the variables. What am I going to put down? A squared is equal to B squared plus C squared minus 2BC cosine of A. Good. As long as you want to make sure that those two pair up. And ladies and gentlemen, with something like this, with a formula that's that crazy, I always write the formula down before I put the numbers in because it starts getting real ugly real fast. So go ahead. I want you guys to see if you can find whatever we're missing. And actually just finish off that problem for me. Try to type them into your calculator correctly, unlike me. Remember, I'm asking you to solve the whole triangle, not just find one piece. hearing good conversation. So how confident are we? Hopefully confident? All right, this is what you should have come up with. And just to kind of prove to you that it doesn't matter, if you know what your largest angle is, if you are certain you know if it's obtuse or not, you got that stuff, then it doesn't matter which side you pick. I actually found each of those numbers, both of them doing law of sines, and it works out exactly. Okay. So what did we do wrong? Yep, you get used to doing all those signs. So you got to be careful with that. Anybody else? Couple folks sounds like did that. Alrighty. Yes. Mm-hmm. Yes. So no matter what you're going to do is you're going to use the law of cosines to say if I give you an angle, to find the sign that pairs up with it. So in this case, I give you an angle, find the side that pairs up with it. Now, one more type of situation. I realize I didn't do this, so I've since fixed it. What happens if all I give you are 3 sides? And I just made that up, so I don't think it's going to work out to be a 30-degree angle. So here, I haven't even given you any angles. How am I going to do this? Well, let's start the way we've always started. I'm going to have angle A, angle B, angle C, A, B, C. I'm sorry? No. I understand where you're going at. What we're going to do, because the law of cosines is going to make sure we don't have to worry about is it acute, is it obtuse, it will work either way, giving me one answer. So what you always want to do is go to your biggest. Use law of cosines on your biggest. What is my biggest? B. So I'm going to use the law of cosines with this. Now, let's just set it up using the variables. Let's not actually kind of work through it quite yet. I want to show you something. Because when you're looking for an angle, law of cosines is definitely a little bit trickier. So if I'm using this, how would I set up my equation? No. And then minus 2ac cosine of b. Now the problem with this is so many people try to just shove the numbers into this formula and try to magically math it around. And the problem with that is you make a lot of silly kind of like computational mistakes. So what I want to do, I want to try to get this piece right here by itself. I'm going to solve using algebra for that. What would you do first? No. Minus a squared and c squared first. Undo addition, subtraction first. Okay, now my goal here is still to get that by itself. What am I going to do? Divide now by... Now, one of the things that I have found causes a lot of issues on this problem, anybody want to guess? Look at all those negatives, right? So what I'm going to do is I'm going to kind of just distribute in. I'm going to take this negative and move it up top. So it'll be negative, plus, and plus. So I will have a squared plus c squared minus b squared all over 2ac is the cosine of b. So rather than having 3 negatives, now I just have 1. Makes life a lot easier, and we tend to make fewer mistakes. And this is when I put my numbers in. Now, some of you have much better brains than I do. My brain broke its memorizing ability a long time ago. I've never been able to memorize. I'm horrible at it. So every time I do one of these problems, I solve for the missing angle. I do, every time. If you have a good memory and you can memorize really well, you are more than welcome to skip straight ahead to this and just memorize that. Just be careful, okay? So now all I'm going to do is plug my numbers in. So I will say a squared plus c squared minus b squared all over 2 times a times c. And I want to make sure everybody knows this awesome thing that our calculators can do. Okay, because that's an ugly looking fraction, right? And to try to make sure we type that into the calculator right can be a little bit difficult. So I don't know if you know this trick. Alpha y equals. It's literally called pretty type. Or at least that's what I was told it was called. And if you go to that first option, that one, it pops up for you a fraction bar. You just type top in the top, bottom in the bottom. So 24 squared plus 15 squared minus 30 squared all over 2 times 24 times 15. Look at how nice that is. Isn't that wonderful that you can do that? I think that's so cool. I used to always forget my parentheses. This kind of cuts out that issue. So then if I want to find my angle B, what am I going to do? Inverse cosine. Beautiful. So inverse cosine of that, boom, there's my angle. So here I have that angle B is 97.903 degrees. Yes, sir. No. Remember, we distributed our negative through here. So that makes it work out. I got 97.903. All right. Now that we know we have our largest angle, there can be no angle bigger than this. That means the other ones have got to be acute. What can you do? Go for it. Because the law of cosines, you can see, sometimes it's nice. When you're looking for the side, sweet. When you're looking for an angle, it's a little bit more work than I like. So go see if you can finish that. Check your answers with each other. Did I do this wrong? 24, sine of that. Okay, I'm hearing different numbers than I got, so let's see. That I got. Yeah? Am I just hearing things wrong? And I do recognize, ladies and gents, that this doesn't feel like it should add up because 3 plus 6 is 9. It's close enough. It's just because the way things round. If you kept going out, it's fine. So, questions? Yes. That's fine. That's fine. Okay? All right, so let me preface problem number 4 with the fact that I don't know anything about golf. Wait. There are sticks and balls and grass involved. That's about my limit of golf knowledge. And flags? Yeah, sure, there's a flag there. Well, look at this. We're building all of this knowledge of golf, just quickly. You don't need to know about golf in order to solve this problem. So what we're going to do here is it says we have a golfer hits an errant tee shot. That means the ball does not go where he wants it to go. Errant means it's off target. That lands in the rough. I assume that's where that's supposed to be. A marker in the center of the fairway is 150 yards from the center of the green. Yeah, thank God they gave us a picture because I don't have any idea what they're talking about. I hope that makes you feel better because I'm sitting there going, what? And it says, while standing on the marker and facing, I guess that's the green, it's 110 degrees towards the ball. He then paces off 35 yards to his ball. So yay, picture! Basically, we just want to know how far is the ball from the center of the green. That's what I want. So, what am I going to use to solve this? Law of sines, law of cosines, regular trig, SOHCAHTOA. What am I doing? Why am I going to use law of cosines? Because I only have one angle, and I do not have its pair. All right, do it. You can finish the rest. The golf question or the law of cosines? Yeah, don't think it's always going to be that case. Thank the Lord for given pictures. Check your answers with your neighbor if you think you got it. It's kind of nice when I don't ask you to solve for the whole thing. Good job, Zach. It was like, no, Zach had the right answer. Okay, let's take a look. Take a look, it's in a book, the reading rainbow. No? Okay. How do we do? Fan-frickin-tastic. Boom! Beast mode math. Yeah. So, one more problem. Can you do it? We can do it. Yay! Yeah, we're doing great. Awesome sauce. Okay, here we go. Read, 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 read. Pay attention, folks. Let's go. There are a couple of you that had issues on this for the first law of science classwork. We had an issue similar to this. By the way, does anybody know what a knot is when they're measuring knots? It stands for nautical miles. So it's just miles on the water. Yeah, I know. I don't know. I didn't make this stuff up. Okay, come on. So happy, happy, joy, joy. They have given us a picture. It's a little dark for you guys. See if I zoom in crazy, you can see it. So here I have that from San Juan to Barbados, it's 600 nautical miles. I have a 20-degree angle here. Now, I want to go from San Juan to Barbados, but I know that there's this nasty storm in the way. So I'm going to go along the side of this. And the problem with when you're on the water, you don't really have a lot of reference points. And sometimes you don't even have GPS, because your GPS is limited to where it can work also. So what they do is they time how long they've been going, and they keep track of a constant speed so that you can figure out where you would be. So I've been going at a speed of 15 knots for 10 hours. How far have I gone? 150 miles. Because again, a knot is the same thing as a nautical mile, so it's the same thing as saying 15 miles per hour. And I've been going for 10 hours. Does that make sense? Okay. Nautical miles. Whatever. Okay, so what we're going to try to figure out is a couple of different things. We want to know through what angle should the captain turn in order to get back to Barbados. So that means I'm going straight. I want to know where I need to turn that way. Okay, so this is what I'm looking for. And then I want to know how long it will take to get there. So basically, let's redraw our triangle. I have 600. I have 150. And I have 20 degrees. And I'm going to need to find two things. I'm going to need to find that and that, where A is the angle. What do I have to start with here? Don't really have a choice. Law of cosines. Because do you have an angle side pair? Not a completed one. So if I'm going to solve for this angle, I'm going to do this, and let's say this way. Let's say 6, and I'm actually going to, again, I don't like doing this with numbers because I have a hard time for some reason. I make more mistakes there. That is, we'll make that angle A. Make that angle B, and we'll make that angle C just for giggles. So that way I will say A squared is b squared plus c squared minus 2bc cosine of a. And we had an equation that we got down to find the cosine. What am I going to do? I'm going to do b squared plus c squared minus a squared all over 2bc. And it's just, to me, I get too confused when I have numbers in that place. I can do it better with letters. Numbers, for some reason, will get me all mixed up. So then I'm just going to say, okay, the cosine of my angle is, I'm going to take the two sides that I have. Wait a minute. Yeah. This should be B. I should be using B. You understand why I should be using B? Even though A is the one I want to find? Why should I use B? Because it's the only angle you have. That's why. You don't really have a choice. One of the things that's kind of irritating with word problems, we tend to try to force ourselves to go in the order of things that they're looking for. That might not be the best choice. Here, that wasn't the best choice at all. Thank goodness for erasable pens. So instead, I'm going to use this pairing. And I'll just call that B. So I'm going to say B squared is A squared plus C squared minus 2AB, or AC, and then cosine of B. So that way, when I put my numbers in, I can actually find stuff. B squared will be A squared plus C squared, which I actually have a number for. I don't need a letter. Minus 2 times 600 times 150 cosine of 20. So be careful. I have a tendency to make that type of a mistake. I'm going to say, hey, the first thing it says is find the angle. So that's what I'm going to do first. You can't always do that. So what did you get for that missing side? And that's going to be in miles. And you know what? Since I'm doing that, and that's kind of actually what we're looking for right here, but it says, it doesn't say how far is it. It says how long will it be before I reach Barbados. So if I'm moving 15 miles an hour, I'm going to divide that number by 15. Did you get your homework written down? Quickly, please. And when I divide that by 15, my answer to B is going to be, how long does it take? Jeez Louise. It's not 31 hours. It's 30 point. Might as well be 31 hours. It's going to feel like it. Good Lord. Hopefully you're on a cruise ship. Ah, it's a cruise ship. Look, it says a cruise ship. Yay. You have things that you can do to occupy your time, because that would really, really stink. Do you imagine being on a speedboat for 31 hours after already writing for 10 hours? No bueno. Okay, so I've been able to get this side now. Are you now able to find this angle? Do it. Do it. Find that angle. Huh? That was a distance. 461 is a distance. You better not be packing up unless you've solved this problem. Well, if I'm hearing 150, you've got something wrong. Because that's not the answer. I'm just... Okay, that was a fun sound. Ooh. You should not get a number that is in the 100s if you're looking for the final answer. All right, since we're going to lose you in I said that is not the final answer. The final answer here, that angle you're going to be turning is 15.266. You have to be careful. If you're going to use, guys, are you listening to me? If you're going to be using law of sines to just find that angle, look at that. That's the largest side. When you do the law of sines, it's only going to give you the acute angle, so you've got to be careful. So you can either stop and find this one first, find that angle because I know that is going to be acute, or you'll have to work through and hope that you're in the right spot. But this angle right here, the angle that you turn, is 15.266 degrees. That is why you got to be careful with the law of sines. Make sure you guys get your homework written down. It's also on Canvas if you've lost it.